Now let's resize the image, and we can resize the image using the OpenCV's resize method. cv2 dot resize. It takes an image at first argument and the height and width as tuple at a second param. So let's make it 400 by 400 and assign it in a variable and name it resized. And now let's show the original image. cv2.imshow original, the original image and the resized image. cv2.imshow resized and the resized image. Now let's run the application to test. Great. We can see our image is resized and its size is 400 by 400 pixel. Well, at the third argument of the resize method, let's go to the project, and here we can pass interpolation, and we can pass three types of interpolation here. Interlinear stands for interpolation linear, and interarea and intercubic. Let's try all these three. Well, if we don't pass any interpolation, then by default it takes interpolation linear. So let's pass interlinear first. Interpolation cv2 dot interlinear. Now area, interarea, and finally intercubic. Let's rename all these. And show all these three images differently. Resized linear, resized linear, resized area, resized area, and resized cubic. And now let's run this application again and check it. And we can see three types of interpolation, and we can see that interpolation type of area shows the image with better resolution. Well, keep in mind that using the resized method, we can also resize an image and make it bigger than actual size. Now let's blur our image, and we can do that using the blur method, the blur method of OpenCV. So let's delete these two and all these three and declare a variable, name it blurred image, and here call the blur method cv2.blur. It takes image at first argument and the kernel size. The kernel size must be a tuple of two values, and the kernel size indicates how much do we want to blur the image. Let's say we want 50 by 50. Now let's show the original image and the blurred image. And now let's run the program to test. And we can see our image and it's blurred. Let's reduce the kernel size. Let's make it 5 by 5. Quit the program and run it again. And we can see the blur, but it's very little. So we could understand if we increase the kernel size, then it will blur more, and if we decrease the kernel size, then it will blur less. Well, we can also do GaussianBlur and medianBlur. Let's try GaussianBlur this time. We will say GaussianBlur. It also takes image at first param kernel size at second param, and an positive integer at third param as sigma x. So let's pass 0 for now and run the application. Before that, let's quit our application, press any key and run it again. Great, we can see it. Because we have passed a small value as kernel size, so we can see less blur. Let's increase it and make it 50. And interestingly, if we make it 50, then we will get an error. Let's quit the application, run it, and we are getting an error. The reason is it takes one odd number, actually a pair of odd number as tuple instead of even number. So if we just make it 51 by 51, then it will work perfectly. Let's run the application again, and we can see it's blurred. Let's try mediaBlur this time. And mediaBlur takes a positive integer instead of tuple at its second param. Let's pass 10 here, delete the third param, the argument, and run it. Okay, let's quit the program again and run it again. We can see we are getting an error. It's also the same type. If we pass one even integer here, then we will get this error. If we pass an odd integer here, it will work perfectly. Awesome. You can see our image and it's a little bit blur. Let's increase the kernel size and make it 100 or 101 actually. Quit the application again and run it again. You can see our image is blurred. Let's quit the application, and now let's try implementing different colors. We can do that using the CVT color method. I'm renaming this variable and making it colored image. Passing colored image variable here, changing the name, colored image, and here we're calling CVT color method. It takes the image we want to implement color on at first param, and at second param it takes color. We have to keep in mind that we need to know the current image color. We know OpenCV's default color is BGR, so we can convert from BGR to RGB and to different colors. So let's try from BGR to RGB first. cv2.bgr to RGB and run the application, and we are running both original and the colored image. And we can see this is the colored image and this is our original image. Quit it, and this time let's do BGR to grayscale. And we can see our image is grayscale now. In the same way, you can try all the different colors. Now let's learn how to add text on an image and how to draw shapes, different kinds of shapes on an image. Let's do that in our next lecture.